Hello everyone, welcome to the next lecture on the differential equation. Today I will explain you the type 2 of the operators method. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the mathematics 2 differential equation, and you can see the various lecture related to the operator methods and example of the operator methods are already uploaded in as the previous lectures. Now in this lecture, we will see how you can find the particular integral when your function, that is the right hand side, is of the polynomial form. This lecture I have already uploaded as my last one, which you can see in this playlist, examples of the operator methods, exponential form. Now in this lecture we will see how you can find the particular solution by the operators methods when your right hand side is my polynomial function. How you can write it, it's a very simple. How you can solve that? For example, I can see this example. Your first target is to write in the form of 4 is a second derivative plus 1 of y, which is equal to x raised to power 4. Can you find the value of the y? It is 1 plus 1 over x raised to power 4. Then whenever you write this value, then you can express this denominator always in the form of -1. Fine. So this, whatever the function you have obtained, it is always be written in the form of inverse. Once you can write in the terms of the inverse, then we can apply the binomial theorems like 1 plus x raised to power -1 or 1 minus x raised to power -1. Make sure, student, when you expand in terms of -1, the first quantity must be 1. The first quantity must be 1. If it is not, like d square plus d, then you can take d as a common, then it is my 1. Fine. Now I will explain you with the help of the numerical examples. I hope you can subscribe my YouTube channel so that when I upload in my next videos, you will get the notification. So find the particular solution of this by the operators method. So I can write this equation is d cube minus 2d square plus 1 of y, which is equal to x raised to power 4 plus 2x plus 5. So therefore your particular solution is, can you find the value of the y? Yp is my particular solution, which is 1 divided by d cube minus 2d square plus 1 into x raised to power 4 plus 2x plus 5. Now since the right hand side is my polynomial, your target is to write up to the -1. So is the 1 appears? Yes, 1 is already there. Then I can write this number is 1 plus d cube minus 2d square raised to power -1 into x4 plus 2x plus 5. Fine. Now since it is written in the power of -1, then we can use as the expansion series 1 plus x raised to power -1. So that will be 1. This is my x, in this case 1 plus x, fine, sorry, 1 minus x, 1 minus x plus x cube, x square, so this quantity square minus cube, then plus power 4 and so on. Fine. Now the question arises is up to what degree you have to written. Look at the right hand side of the given function. What is the polynomial degree? The maximum degree is my 4. So you have to write only those quantities up to the degree 4. Fine. Now if you open this bracket, look at only those degree of the d which has value less than or equal to 4. So like this is the d cube, this is less than or equal to 4 plus 2d square. If I use as a minus b whole square, the first quantity will be the d6. Fine. And the degree is more than of this, so we can ignore them, plus 4d raised to power 4. And then 2ab is a minus 4d raised to power 5, which is more than of the degree. So skip that. If I use as a minus b raised to power cube, is a cube is a 9, then it's a 6, then no term which is less than of the 6. I can write only up to this value. Fine. And then I can written as x4 plus 2x plus 5. Now you can open this bracket, 1 into x4 plus 2x plus 5. What is a capital D? Capital D is my d over dx. Then what is that capital D square? Is the second derivative. D cube is the third derivative. So can you find the third derivative of this? The first derivative is x 4x cube plus 2. Second derivative is 12x square. Third derivative is 24x. Fourth derivative is 24. So I need the third derivative. So third derivative is 24x plus twice d square. That is the second derivative. This is the first derivative. This is my second derivative. Plus 4 times fourth derivative. Fourth derivative is my 24. Now you can open this bracket. It is x raised to power 4 plus 24 into x square. 24 and 2 is the minus 22x, and 24 into 4 is the 96 plus 5. This is 101 is the 101 is the right answer of this problem. Always expand this form and you can get the right answers. Don't worry, I will explain you the 10 more examples in this lecture so that you can understand it more deeply. You can watch this lecture till the end so that you can understand the various cases in a very simple manner. Look at the second example. Don't forget to like and comment on the video. So how you can write that? It's a d square minus d plus 1 of y. Fine. Now look at that, the right hand side. The degree is my 3. Then you have to consider only those powers where the maximum degree is my 3. So can you find the value of the y? Y is my this. Now since already 1 appears, then I can write this number is 1 plus d square minus d raised to power minus 1 into x cube plus 3x square plus 1. Fine. I can again use the expansion 1 plus x raised to power minus 1, 1 minus x plus x square minus x cube, and so on, because I need a maximum degree 3. So I can return up to the degree 3. Now you can open this bracket, 1 minus d square plus d. It is a d raised to power 4 because we need a degree 3, so I can skip that, plus d square minus 2ab minus 2d cube. In this case, is there any term involvement of the d cube up to? First one is a 6, it's a cancel out. Then is a d cube minus of the d cube. Fine, 3ab and cancel out. Fine. So now you can open this bracket. What will happen? D square will be cancelled out. So then it is 1 minus, it's a plus, it's a minus d cube plus of d, and this is the expansion of x cube minus 3x square plus 1. Now that's over. Now you can open this bracket, x1 into this, fine, plus first derivative is 3x square minus 6x. Then we need the third derivative. So first derivative is 3x square minus 6x, second derivative is 6x minus 6, the third derivative is my 6. Fine. Now you can see that x cube 3x square cancel out, x cube minus 6x minus 5 is my right answer of this problem. Look at this another example. Again, your target is to firstly write in the terms of the capital D, and you can find the value of the y. So y is my 1 over this number. Now already 1 appears. So if you write this quantity as 1 over d cube plus d square plus d raised to power minus 1, then because my degree is 5, then you have to write the series is 1 over d cube plus d square plus d of square, similarly plus cube minus power 4 plus power 5. But you can see that how you can open this, it is like a plus b plus c whole square, that we all know, a square plus b square plus c square, 2ab 2bc and 2ca. How you can open this cube? Moreover, how you can open this power 5? Do you remember the formula of a plus b plus c raised to power 5? No. Fine. So that means the calculation becomes so lengthy. So in order to understand this calculation easier, I can think about the term of the denominator firstly. Fine. Now you can see that I can write the first value is 1 plus d square plus d cube. Now, if I multiply and divide it by 1 minus d, fine. So the numerator part becomes my 1 minus d raised to power 4. Fine. So I can substitute this value is 1 minus d raised to power 4 and it is 1 minus d. Fine. Now that's over. Now you can open this bracket. The first part is 1 minus d raised to power 4. I can firstly open this bracket. X raised to power 5 minus 2x square plus x and minus derivative of this. The first derivative is minus x4 minus minus plus 4x minus 1. So that number becomes my 1 minus d raised to power 4. It's a x raised to power 5 minus 5x raised to power 4. Then it's a minus 2x square, 4x and 5 is a plus 5x minus 1. Fine. Now you can write this expansion is minus of 1. This is the expansion of x raised to power 5 minus 2x square and so. Now you can write this series. What is the expansion of the 1 minus x? Is the 1 plus x square plus x cube and so on. You have to write until the degree 5. So 1 plus x square. So if you write as x square, it's a d4. So that means all those remaining powers are more than of the degree 5. Fine. Now you can open this. Now up to this. Firstly, you can open this 5 minus x raised to power 4 minus 2x square plus 5x minus 1. Find the fourth derivative of this. The first derivative is 5x4 minus 20x cube minus 4x plus 5. Find the second derivative 60x square minus 4. Third derivative 60x square 120x. Fourth derivative 120x minus 120. Fine. So fourth derivative is it's a minus 1. The fourth derivative is my plus 120x minus 120. Find the eighth derivative. You can see that it's a fourth derivative. Eighth derivative is my 0 and then rest are 0. Now you can write these expansions and you can simplify that. So you can see 5x4 and that is the right answer of this problem. It's a 120 and 5 is 125. Okay, again find the particular solution. You can write this series, this function in terms of the capital D. Fine. And find the value of the y. So since it's only the consists of the two terms and one is already appear, I can return this part is 1 plus d cube minus 2d raised to power minus 1. I can expand the series 1 plus x raised to power minus 1, 1 minus x plus x square minus x cube plus x4 and so on up to the degree 3. So I can write up to the degree 3. Now you can open this. It's a 1 minus d cube plus 2d. If you open this square, the first quantity is the d6 plus 4d square minus 2ab. So since I need up to the degree 3, so the d6 will be cancelled. The only quantity here is my d square and this is the 4. I can cancel that. In this case, if you written as a minus b whole cube, which value is degree is less than or equal to 3? Only this number, that is my minus 8d cube. Fine. And the rest values are my cancel, or you can say the higher degrees are there. So now you can see that it's a plus 8, this is a minus 1, this is 7, 1, 7 is a 4 and this. Now you can open this bracket, that will be the right answer of this problem. 3x square plus 4x plus 5 plus twice of the first derivative. What is the first derivative? 9x square minus 6x plus 4 plus 4 times second derivative, because this is the first derivative. Second derivative is 18x minus 6 plus 7 times third derivative is my 18. The rest powers are cancelled. Now you can open this bracket. 3x cube is the single term, is a 18x square minus of 3 plus 15x square is a minus 12x. This is a plus 4x, and this is my 72x. So you can add them. Is a 60 and 64. X is my correct answer, and you can see the constant part is this one. I hope student you can like and comment on this video as well. You can share this video with your friends also. Now you can see I can write this expansion series is 4d square plus 1. Find the value of the y from this case. Now already a 1 appears. So I can write this series is raised to power minus 1 x raised to power 4. Then I can expand them with the help of 1 plus x raised to power minus 1 up to the degree 4, because the next term will be my degree 6. Fine. Now you can open this bracket. It is a x raised to power 4. What is the second derivative of x raised to power 4? First derivative is 4x cube. Second derivative is 12x square. Plus, what is the fourth derivative? The third derivative is 24x. The fourth derivative is my 24. And the rest values are my 0. Now you can open these brackets. Minus 48 into x square. Plus, you can multiply the 16 into 24. You will get the right answer. Look at this one. How you can write that? This is the d raised to power 5 minus d raised to power cube of y is equal to x square. Can you find the value of the y? Y is 1 over d raised to power 5 minus d cube. Now you can see that in this denominator 1 is not present. Fine. So 1 is not present, then you can find the value of, you can consider that as a 1. There are the two ways how you can do that. Firstly, if you consider d raised to power 5 as a common, then it will be 1 over d square. The second way is you can consider as a minus of d cube as a common, then it is 1 minus d square. Now which one is the accurate way? You can see that what is the meaning of this? The degree is my minus of 2, so you can avoid this case. Fine. Whenever you want to expand the series, either the 1 plus x or 1 minus x, you always need a degree is positive. So that means I can consider minus 1 over d cube as a common, then it will be minus 1 over d square. Fine. Always remember, if firstly you need a 1 and the degree should be positive. Now you can expand them. I can written is a 1 over d cube into 1 minus d square raised to power, because 1 is appearing only for this quantity, I can written as this quantity. Now you can expand this series again with the help of 1 minus x raised to power minus 1. It is 1 plus x square plus x cube. So this will be minus 1 over d cube, 1 plus x square, because I need up to the maximum degree 4. So we already obtained the degree 4. We can stop them. So that will be minus 1 over d cube. I can open this bracket. It's a x square. Second derivative is 2. Rest values are my 0. Fine. Now what I told you, d is my d over dx. So what does it means? 1 over d. It is my integration. So what is the meaning of the minus 1 over? That means it is my triple integration of the x square plus 2. So what is the triple integration? If you first consider what is the x square integration is x cube over 3 plus 2x. Because it's a particular solution, so there is no need to write the C1, because the particular solution is those solution which does not involve the constant. Then x cube plus 3 plus 2x. Find the second integration. So it is x raised to power 4 over 12 plus x square. Then find another one is x raised to power 5 over 60 plus x cube over 3. So the answer of this is minus x raised to power 5 over 60 plus x cube over 3 is the right answer of this problem. Fine. This is basically my third derivative of x square plus 2. Look at this another one. Again you can write this number is d6 minus 1 of y, which is x raised to power 10. Can you find the value of the y from this? It's a 1 over d raised to power 6 minus 1. Now, always remember you need either as a 1 minus x and 1 plus x. So I need a 1 which is of the positive number. So here in this case is a negative. I can take a minus 1 common, then it is 1 minus d raised to power 6. If you consider as a d raised to power 6 common, then it becomes this is my negative power. So that's why this option is cancelled out. Then you can write 1 minus d raised to power 6 in this power. We can expand up to the degree 10. So 1 minus x, 1 plus x square. If you consider the x square is at 12 and it is more than of the degree 10. Fine. Now you can find this value. If you open this bracket, it is x raised to power 10. Find the sixth derivative. First derivative is this. Second derivative is 10 into 9, x raised to power 8. Third derivative is 10, 9 into 8. Fourth derivative is 10, 9, 8, 7. Fifth derivative is x raised to power 5. And sixth derivative is 10, 9, 8, 7, 6 and 5 of this. So I can write this number is 10 into 9 into 7 into 6 into 5 of x4. Can you find the 12th derivative of this? Because the degree is more, so the 12th derivative is my 0. So the right answer of this problem is 10, 9, 8, 7, 6 into x raised to power 4. So that will be x raised to power 4. Look at this another one. Again, you can write in the capital D form, which is my d square plus d minus 1. You can find the value of the y. Already a 1 appears, but it is of the negative sign. I can take minus 1 common. So then it will be 1 minus d of form. Fine. Now you can write this number. I can take it as a negative common. Then it is my 1 minus d square plus d. I can write in the terms of the power. Again, I can expand this series with the 1 minus x. It's a 1 plus x square and so on until up to the degree 4. So it will be minus 1 plus this first part plus d square plus d up square plus d square plus d cube plus d square plus d power 4 up to 3x minus x power 4. Now you can open this bracket. Up to the degree 4 is a 1 plus d square plus d. If I use a plus b whole square, the first value is the d4. Second is my d square. 2ab is a 2 times d cube. Plus I can use a plus b whole cube. So what will happen if you open them is a d raised to power 6 plus d cube plus 3 d raised to power 5 plus 3 d raised to power 4. Since I need up to the degree 4, that is only the 2 quantities. Similarly, for the last part, only this d cube will be appears. Now you can combine them. What will happen is a 1 d square, 1 d square, that's a 2 into d square. Similar 1 d also there. Similarly, cube you can combine them and power 4 you can combine them. Now open this bracket. It's a 4 times. Can you find the fourth derivative of this part? The first derivative is 3 minus 4x cube. Second derivative is minus 12x square. Fourth 24 and then minus 24. So this number is my minus 24 plus the third derivative is minus 24x plus second derivative is minus 12x square. First derivative is 3 minus 4x cube and plus 1 you can multiply them 3x minus x4. Fine. Now you can open all these brackets. You will get the right answer as this one. Dear students, I hope you can like and comment on this video and share this part with your students as well. That's very simple. I can write this series, this given differential equation is d square plus 1 is equal to x4. You can find the value of the y. Since already 1 appears, so I can write easily d square raised to power minus 1. Now I can expand this series 1 minus x plus x square minus x cube and so on, because I need up to the degree 4, so we get x raised to power d raised to power 6, so I can use as the man. Now you can open this bracket. You can see if I open this bracket, it's x4. What is the second derivative of the x4? The first derivative is 4x cube, second derivative is 12x square. And what is the fourth derivative? Then it is my 24x, and the fourth derivative is 24. So that is the right answer of this problem. Okay, look at this another one. Quickly find the value of the y. I can written as a d cube minus d square, and the y is my this part. Again, because the 1 is not given, so and if you consider the d cube as a common, then it is 1 over d, which is a negative power. So I can consider minus 1 over d square as a common, so that it becomes a plus 1. So 1 minus d of 12x minus 2. Now I can write this as a power of minus 1, and then I can expand this series up to the degree 1. So it is a 1 plus d square. It's a power 2, so I can skip that. Fine. Now it is minus 1 over d square. I can open that. It's a 12x minus 2. Find the first derivative, and the second derivative is my 0. So this number is 12x plus 10. Fine. Now I can written this is 12x plus 10. Now what is the meaning of this d square? That means the double integration of 12x plus 10. So can you find the double integration of the first integration will be 6x square plus 10x. Second integration will be x cube by 3. So x cube, and it's a 5 times x square. So the answer of this problem is minus 2x cube plus 5x square is the right answer of this problem. 2x, sorry, it's a cube. 2x cube. First integration is x square, second is x cube. So it's my cube, and it is my 5x. 2x cube plus 5x square is the right answer. Look at this another one. Quickly write the value of the capital D. It will be the capital D cube plus d square. Again, if you consider as a d cube, because the 1 is not given, so you can consider the d cube as a common, then it will be 1 over d, which is a negative power, so you can skip that. I can consider the d square as a common. It is 1 plus d. I can write in terms of the d plus 1 raised to power minus 1. Now I can expand the series up to the degree 2 only. So it is 1 minus d plus d square. The next term will be d cube. So I can stop. This will be 9x square minus 2x plus 1. Now open this bracket. It is 1 over d square. If you write as a 1 into 9x square minus 2x plus 1. Minus d is the derivative. Find the first derivative. Minus 18x minus minus plus 2. Find the second derivative. Second derivative is my 18. Fine. The first derivative is 18x minus 2. Second derivative is my 18. Now you can combine them. It's my 20x. It is my 21. Fine. Now what is the meaning of that? That's the second derivative, second integration of 2 times integration of this component. So can you find that 2 times? The first integration is x cube by 3. So 3x cube minus 10x square plus 21x. The second integration will be 3x raised to power 4 minus 10x cube by 3 plus 21x square over 2. So the right answer is 3 over 4 x raised to power 4, 10 over 3 x cube, and 21 over 2 x square is the right answer of this problem. Fine. So you can see that it's a very easy way you can expand the series. Always remember the simplest way. Your target is to make them as a 1. These 4 questions are exercise for you. First 4 questions, again you can see it's a polynomial. You can write this in the form of the capital D, and you can let me know whether your answers will match. Like if you write in this quantity, it's a 1 over 2d square plus 3d plus 4. Now since 1 is not be given, so I can take 1 over 4 as a common. So it is 1 plus 2d square plus 3d divided by 4. Fine, your target is to make them as a 1. Similarly, for this case, you can take 3 as a common. These are another 3 questions are exercise for you. All are my up to the degree 2. Fine. So you can solve these 7 problems and verify your answers and let me know whether your answers are matching with this case or not. Remember, they are talking about this solve the problems. That means you are talking about the complementary solutions plus particular solution, both at the same. In the next lecture, we will see the case 3 when the right hand side is my exponential as well as the product of the case. That will be upload the next lecture very soon. Till then, you can share this video with your friends and don't forget to subscribe my YouTube channel. Thanks for the support and thanks for the watching this video. Best of luck, students. Happy learning.